everybody. My name is Margaret. I'm a founder and CEO of Lighting Charge Solutions LLC. And today I would like to start with talking about the bigger picture. What's the big problem? We live in the world of electronic devices, and the problem is that only about 30% of all electronic waste is being recycled. And that's a big problem. And why is that? Because most electronics currently employ heavy elements as well as toxic heavy elements and rare earth materials. And right now we actually have on our landfills more rare earth metals than we do in our mines, and that's a big problem for us in the future. What we need to do now is rethink how we make these devices, start to find ways of recycling and reusing some of these materials for future of the improved devices of electronics that we're currently using. Well, how can we do that? We can move towards the area of what's called organic electronic devices. We have organic lighting and diodes here as example, or OLEDs, which are currently used in displays of TVs, cell phones, and other displays. We can see here in a picture already visually, OLEDs look more natural to the human eye. They're more pleasant, they're brighter, they have higher contrast. They're also safer. The devices are much thinner and lighter and consume less power. So there are a lot of great benefits. But we still have issues. We have limited lifetime for such devices. The manufacturing is very expensive and they are sensitive to moisture. What are the OLEDs? Actually, let's dive a little deeper. They're these sandwich layer devices that allow the light to be emitted. The most important layers that you need to remember from this picture are cathode, anode, hole and electron transport layer, and the main component light emissive layer that allows for light to be emitted. But as you can see from this picture, you don't just see those 5 layers. You have a lot of different layers. And reason for that is actually lack of appropriate electron and hole transport layers to match the materials that are used as emitting layers for electronic devices. And the reason for that is the complexity of the performance needed for each of different applications of OLEDs. So our solution is to produce materials that are color tunable, architecturally adaptable, stable, earth abundant, and importantly scalable. Our technology goal is ultimately to move from these complex, expensive structures to printable single-layer devices. How would we do that? A synthetic platform that can be very easily tunable. It is based on all earth-abundant materials and elements. And we can see here, we can tune anywhere from blue light to red light. We can make different solid-state films. As well as these materials are they have quite high quality and are architecturally adaptable, as we have demonstrated on the right in different kinds of organic devices. We have photovoltaic solar cell, organic lighting and diode, and field effect transistor, which proves the versatility of such technology. We have also done very extensive customer discovery with NSF I-Core in the last few months. And we traveled across the United States, talked to the US and internationally known companies to understand, is this really a big problem in the industry, and if we can solve it for these companies. And what we learned that this is a very quickly growing industry, and it's multi-billion-dollar industry actually. And even though the display industry is taking a hit with current events, the forecast is that the display industry will quickly recover, pick up the pace, and will have new needs, where we will be able to accommodate these new needs. Our go-to-market strategy will be to launch our pilots, receive feedback from the customers that are willing to provide that feedback, and be able to generate our first generation of materials for sale by 2021. But the 5-year mark, we're hoping to have 2 to 3 long-term customers, which will be able to produce on the scale of 30 to 40 kilograms a year and bring revenue of about $3 million a year. And before the 10-year mark, our goal is to reach our target market of $10 million with these materials. And with that, I would like to thank you all for your attention, and I would like to hope that I've motivated you to support a safe and sustainable future. Thank you.
So what we have actually seen is the top 4 team presenting their innovative idea and product. So without any further ado, I'm going to share this slide deck and announce the winners. Great. So I have this slide deck here. So we are so excited and happy to announce the winners. As you see, at the graduate level, the first place goes to Light and Short Solutions from the University of North Carolina at Charlotte. And the second place goes to Margaret team from Duke University. So this year, we are so excited to get 31 intents, 21 full submission from 5 universities. Each of these innovative products are highly competitive, and the judges had hard time picking the top 2 from each category. So the details in these innovative ideas, as you've seen, show the depth of the knowledge, the level of research they've done, and the quality of the prospective products awaiting to come to the market. So on behalf of all the board members from the PDMA Carolina chapters, I would like to thank all the sponsors who enable the prize money, all the students for their hard work, which is put into this research to develop these innovative ideas, the faculties who are guiding and encouraging these students through their invention journey, and the judges who gave their professional expertise and their meticulous time to look into the details of each of these submissions and gave their feedback. I would also like to thank everyone who was involved in the student competition, including the audience who are here to encourage these students. So thank you all.